Hello and welcome to the third in this series of tutorials about fractions. In the first tutorial we gave an overview and we talked about converting from mixed numbers to top-heavy or improper fractions. In the second tutorial we talked about how to simplify fractions by identifying common factors and cancelling those, and we tried to give in each of these cases some conceptual background. I'm now going to talk about arithmetic with fractions, and just in order to make good time, given that your time is so precious, I'm not going to give so many conceptual examples now, but more about what manipulations will you need to make in order to do these calculations. Let's just start though talking about multiplying fractions, because that's the simplest arithmetic manipulation you can do with fractions. So we're going to start by thinking about multiplying fractions. When we think about arithmetic with whole numbers or with integers, we know that adding is the simplest thing we can do. Taking away isn't too bad. Multiplying is harder and dividing is harder still. It's different with fractions. When you do arithmetic with fractions, it turns out that the easiest thing to do with two fractions is to multiply them together. Dividing is also very straightforward. It's very similar to multiplying, as we'll see shortly. Slightly harder is adding and subtracting fractions, and I'm going to cover those two things in the next tutorial. Here I'll just talk about multiplying and dividing fractions. Let's start with a very simple example, just to give some conceptual context. Imagine I have a cake which I cut into two halves. And then imagine with one of the halves that I cut it again into a half. And I ask, what fraction is this piece of the original cake? It is half of the cake. When we frame a maths problem and we use the word of, we are often essentially meaning multiplying. Okay, so half of a half is half times a half. Obviously from the picture, this is 1/4 of the cake. And indeed, the manipulation that you would make if you were trying to multiply two fractions is the following. Two fractions multiplied together, you take each of the numerators and you multiply those together all over each of the denominators multiplied together. And then you just do these multiplications on the top and the bottom and see what you get. 1 times 1 is 1, and 2 times 2 is 4, and we get obviously the right answer of 1/4. Let's just do a few examples which I'll just make up very quickly here. So imagine we have, let's see, 2/3 multiplied by 3/5. We can just multiply the tops and divide by multiplying the bottoms. Now you might see that we have a common factor on the top and the bottom, and we could, if we wished, just cancel those out to get 2/5. Alternatively, we can just keep going. 2 times 3 is 6, 3 times 5 is 15, and then 6/15 is a valid answer to the question. It can be simplified down to 2/5 because there is a common factor of 3 on the top and the bottom. Let's do another example. 3/7 times 2/11. Slightly harder one. We just multiply the tops together, divided by multiplying the bottoms together. 3 times 2 is 6. 7 times 11 is 77, and that would be the answer. So you see, multiplying fractions is really quite straightforward. If you have a problem where you are multiplying mixed fractions together, you would first need to turn them into top-heavy fractions. So for example, if you had the problem of, let's say, 2 1/4 multiplied by 1 1/3, you would first need to convert each of these into a improper fraction. So 2 1/4, let's use the quick method that I mentioned in the first tutorial. Take this number, multiply by the whole number, and add to the top all over this number. So 4 times 2 is 8, plus 1 is 9, all over 4, multiplied by 3 times 1 is 3, plus 1 is 4, over 3. That's quite funny. I seem to have lots of cancellations here, which was not at all my intention, but there you go. So there's lots of common factors here. Let's multiply the tops together. 9 times 4, divide by the bottoms. Do you see I have a common factor of 4, which I can cancel, and I'm left with 9 over 3, and then I can write 9 as 3 times 3, and I can write 3 as 3 times 1, and I have a common factor of 3, and I'm left with 3 over 1, which is 3. You may have just said here, well, 9 divided by 3 is 3. So I'm just going through the motions with fractions, but you, of course, could quite straightforwardly just say, well, 9 divided by 3 is 3. Well, that was quite unexpected that those two mixed numbers multiplied together actually give a whole number. So, just to recap, if you do have fraction multiplication involving mixed numbers, you need to turn them into improper fractions before you continue. Let's talk about division. Dividing fractions. This turns out to be, I can't resist saying it, a piece of cake, because if you know how to multiply fractions, you sure know how to divide fractions. There's only one additional step, and it's a very simple step. So let's just make up an example. Let's imagine the example was, let's see, 1/2 divided by, I'm just making this up, let's say 3/5. That looks quite horrible, doesn't it? However, don't fear. When you're dividing fractions, you simply need to switch the division sign to a multiplication sign and flip the second fraction. Now you might say, well, why is that true? And here I'm sort of giving you more of a mechanistic way to go about the operation of dividing. In the next but one tutorial on fractions, I'll be talking about manipulating fractions in algebra, and we'll go into more detail about why this kind of operation is correct. But I think when you're dividing fractions here, it's good to just have a mechanistic way forward. And so we flip this second fraction. We now proceed with fraction multiplication. 1 times 5 over 2 times 3. Do these little sums, so that's going to be 5 divided by 6, and that's the answer. 1/2 divided by 3/5 is 5/6. Let's just do another example where we maybe start with improper fractions. So let's say we have 1 1/5 divided by 2 1/4, for example. Okay. Need to turn each of these into an improper fraction first. 1 1/5 is 5/5 plus 1/5, which is 6/5. Alternatively, you can take this times this plus this over 5, whichever way you prefer to convert mixed fractions to improper fractions. Divided by 2 1/4. We've already seen that 2 1/4 is 9/4. 2 is 8 quarters plus 1/4 is 9/4. Now we convert this to a fraction multiplication problem. We replace the division sign by a multiplication sign, and we flip the second fraction. We simply turn it upside down, so the denominator goes to a numerator and the numerator goes to a denominator, and there we just have a fraction multiplication problem. We have 6 times 4 is 24, and we have 5 times 9 is 45. This can be simplified. We can recognize that we have a common factor of 3. We could see that here, that 6 is 3 times 2 and 9 is 3 times 3. So let me just write that here, that 24 can be written as 3 times 8. 45 can be written as 3 times 15. Those common factors can be eliminated, and we have 8/15. So dividing fractions, very, very similar to multiplying fractions. You simply need to convert the division problem into a multiplication problem by flipping the second fraction. And as I say, we'll delve more into why this is the correct procedure when we talk about the algebra of fractions. Good. I hope that was helpful, and I'll see you in the next tutorial where we work on the slightly harder topic of adding and subtracting fractions. See you then.